So, good evening. Am I audible? Huh? Okay. Good evening, everybody, and thank you for coming here. We were ready to start the program. So, before we start the program, I just wanted to set the mood for the program. So, as you might be aware, that India as a country has very ambitious plans for uh, converting up to half of its entire generation capacity into non-fossil fuel based generation by 2030. So that means that we are moving towards a goal of 500 gigawatts of renewable energy by 2030. So this kind of energy transition, the key vehicle is the electricity grid, the power system of India, which is one of the largest machines in the world. And today we have assembled here a bunch of experts who are going to talk about various aspects related to this energy transition. We have brought the regulatory perspective, the perspective of the manufacturer, the storage, the independent power producer and developer, and of course the transmission system operator. So without any further ado, I would like to request our Dean R&D, Professor Khare, to come here and present the welcome address. Professor Khare, please.
Very good evening to all of you. It's indeed a great pleasure for me to be here, part of this very important event, a panel discussion on challenges and opportunities for large-scale RE integration, a 2030 perspective. Nothing could be more relevant than this theme in today's day. It's very on personal note, I extend a very heartening welcome to our esteemed panel members. Sri Sushanta Kumar Chatterjee, Chief Regulatory Affairs, Central Electricity Regulatory Commission. Sri Sushil Kumar Soni, former advisor and CEO, Grid Controller of India Limited. Sri Ajay Bharadwaj, President, New Business Renew. Sri Devi Prasad Das, Executive Director, India IESA and Customized Energy Solution. Professor Abhijit Abhyankar, NTPC Chair Professor, Department of Electrical Engineering at IIT Delhi, who is the moderator in today's session. It's also great privilege for me to welcome Ms. Vaishali Nigam Sinha, Chairperson, Sustainability, Renew, and other guests from Renew, dear colleagues and students. Today's context, as I already highlighted by the coordinator, Professor Nilanjan Sen Roy, we have to gear up now for large amount of renewable energy generation and its integration into the grid in next coming years. India has set a goal of about 500 gigawatt of non-fossil fuel based electricity installed capacity, and to remind by 2030, and to remind you, we have about 175 gigawatt capacity now. So there is a challenge. Challenges are also multifaceted in terms of intermittency and variability of the source. When we talk of non-fossil based electricity, we mainly talk about solar and wind. So they have lots of variability there, and so that is one challenge. And when such variability and fluctuations are there, grid stability and frequency control is another problem which we have to tackle. So because the grid requires constant voltage and power flow, the variability of these sources cause fluctuation in frequency, and that can lead to power outages and other kind of damages. So that is second challenge I have been told, for which we require advanced control systems for grid stability. Third issue is that most of such power sources, for instance solar or wind, they are located far away from the population. So transmission and distribution system is another challenge actually, where you need to upgrade the transmission and distribution infrastructure tremendously to meet such challenges. Energy storage is another aspect which one has to look into. The renewable energy sources are inherently intermittent in nature, so you need to complement them with very stable energy storage systems to provide the electricity during the period when renewable energy production is low. Finally, but not the least actually, regulatory and market structure. Policymakers, regulatory bodies and market players have to come together to see that this integration becomes a commercially viable options for coming generations. So overall, we require lots of consideration in planning, the innovations, investments and coordination. So today's panel discussion is going to talk about these. All our esteemed panelists. They are great people in their own domain, and we can hear lots from them how we can move forward in this direction to achieve the goal set by our Honorable Prime Minister. Also, it's time when I say that we are proud of the fact that we established Renew Center in 2017 here. This is one of the oldest center of excellence in IIT Delhi, realizing that soon we have to move to the renewable sources of power and electricity. And we have accomplished about 12 projects in this period through this COE, and some of the achievements have been very significant. For instance, very first project was on flexibility of power grids in context of large scale grid integration of renewable energy. I think after lots of careful studies, they have recommended certain strategies to tackle the problem I already highlighted. So, and moreover, they have 2 startups, many publications, and they are also continuing more projects in this direction. I congratulate Renew team and the coordinator for actually helping all of us, and with their help, IIT is also proceeding in the direction of meeting national goals. So with this, I once again welcome all of you and thank you for your participation in this important event. And I welcome you all and request Ms. Vaishali Nigam Sinha, Chairperson Sustainability Renew, to give the welcome address.
Virtually, yeah.
Yeah, so she will be virtually giving the address. I request Madam Sinha, please. Thank you. Thank you.
Can I be heard?
Hello. Yeah, we can hear you. Please continue.
Oh, okay, great. Thank you. Sorry, it wasn't clear to me, but very good evening, and it is my pleasure to welcome all of you to the Renew Center of Excellence's Thought Leadership Series. It's been a while when I heard that the Center of Excellence is one of the oldest centers in IIT Delhi. It really gives us a lot of fulfillment to that. We were one of the first few, and we've been able to pioneer something at an esteemed institution like IIT Delhi. This Center of Excellence was very at Renew, and and the journey really continues, and the support we've got from IIT, the support we've got from the students has really been heartwarming. So once again, I'd like to thank everybody at IIT for giving Renew the opportunity, and the students in particular, and all the professors. It is indeed a pleasure to be at today's session, though I can't be there physically, but I'm glad to see that things we've planned are really being done in a systematic way and in a sustainable way at the Institute. So the industry academia partnership, just to go back a little bit, was actually started under the aegis of the Honorable President of India, Shri Pranab Mukherjee, in 2016. And at that time, it was an MOU we had signed. And as all of us know, sometimes MOUs remain MOUs. But I'm so glad that we all worked very hard towards making this a possibility. And it was the leadership at IIT Delhi, and I think Suman's commitment to his alma mater, which he is very, very proud of, and always inspired by, that we have been able to take our work at the center, from issues relating to R&D to other issues which have been on women empowerment, providing scholarships to, and funding startups, and a lot of other leadership engagements, where we able to bring students, I guess, in our company, interact with professors here as well, where the R&D and the real world sort of activities are moving hand in hand, hopefully to add value in our very unique specific zones. So I think that is the unique part of the Center of Excellence. And, as we just heard, the fact that we are being able to help IIT meet their goals, and hence the government's goals, and hence the nation's goal, it's important. It's good to see that that's happening. And if I could add to the list that it's also helping Renew meet its goal, because I think industry academia partnership is really critical for a new sector like the renewable energy space, where we really need to, focus a lot on issues where there are, which need to be solved for us to do and deliver in a more effective and an efficient way. Um, um, we need R&D to be able to decode the various opportunities which we believe are going to be emerging in future. I mean, so much of R&D around nature-based solutions, around transmission, various challenges require double clicking on R&D to see how we can learn from there, and take a long-term view to solve for problems which the industry is facing. So just a little bit on, I guess, the topic in hand, which we have today, which is challenges and opportunities for large scale RE integration, right? I think some of the problems which we see in the sector for a decade are things around intermittency, transmission and distribution related constraints. How can we solve for them? How can we look at energy storage? And the kind of research we can do at a center of excellence in India with the students and the academia, with the sensibility and the R&D which has been built around the work being done in India is quite unique. Because when you're doing research for, let's say, storage related solutions in a different part of the world, there are different challenges. But in India, you have other challenges like, how do we ensure that there is efficiency in high temperatures, in places where we need storage. And so I believe, and we all believe, that it is the center of excellence at IIT Delhi and other institutions at India who are positioned to come up with R&D. So we do work a lot with institutions around the world, but there are some very unique topics which we can cover, which are local. Also, so I want to say that once again, congratulations on this initiative. I look forward to many interesting topics, conversations, guests and experts, various stakeholders coming together to discuss and identify new ways together with each other, and I'm confident that only our journey to meet our goals, the ambitious goals our Honorable Prime Minister has set, a target of 500 gigawatts by 2030 is no mean feat, and we all have to work together, industry, academia, students who are the future. I wish all of us the very best to be able to come up with innovative solutions yeah, and do more effective and collaborative work together. So thank you and all the best.
Thank you very much, Vaishali ji, for your address. Yeah, we will start. I now request Professor Abhyankar to take over the session. Professor Abhijit Abhyankar is a professor at IIT Delhi. He is the NTPC chair professor currently at the EE department. He was a member of the Global Future Council on Clean Electrification of World Economic Forum, and he is currently serving as member of senior executive group of World Economic Forum's Clean Power and Electrification Program. He has acted as an expert member of various committees established by Central Electricity Regulatory Commission to provide technical support to resolve various regulatory issues. He was also a member of the task force on the transmission pricing review constituted by CERC. So I request Professor Abhyankar to come to the stage. I request all the other panelists to also come to the stage and take their seats.
Well, thank you, Professor Sen Roy. Before I start, there are a few instructions. One is those who have joined us online through WebEx link, you are requested to put your questions in QA box available on WebEx. And towards the end of the session, we'll make sure that the relevant questions will be taken up for discussion. Thank you. First of all, I would like to thank all the panelists who have taken out time out of their busy schedule on behalf of IIT Delhi. I extend warm welcome to them and a big thank you. I'll start by introducing our esteemed panelists. So today we have Dr. Sushanta Chatterjee. Presently, he is Chief of Regulatory Affairs with CERC, Central Electricity Regulatory Commission. And he has a long experience of dealing with power sector reforms, especially the regulatory reforms, since its inception in 1998. He is a Fulbright scholar and has been a postdoctoral research fellow at Harvard Kennedy School, USA, holds a PhD in management, MBA in finance, and master's in economics. He has published several research papers on renewable energy, energy policies, and regulations. He has three books to his credit, published by reputed publishing houses like Oxford University Press, Sage, etc. He has played a key role in implementing policies, regulations on electricity market design and renewable integration in India. He is part of several committees, both at national and international levels, and is a visiting faculty at institutions within and outside India. So welcome, Dr. Chatterjee. Next, we have Mr. S.K. Suni. He's a former advisor to POSOCO, now Grid India. And he is founder CEO of POSOCO then, currently, which is now Grid India. He is distinguished alumnus of IIT Kharagpur and fellow of IEEE. Mr. Suni specializes in power system operation, planning, commercial settlement, restoration, and entire gamut of power pooling and governance. Other areas of interest include electricity markets, open access, regulatory affairs. Besides, His expertise in load dispatch technology, integration of renewable energy, including REC mechanisms, transmission pricing, and development of ancillary services. He has first-hand 4 decades, long 4 decades of experience of power system operations of various regional grids in India, and has worked passionately towards integration of grids, leading to the formation of National Grid and now the SARC grid. He has represented India on SIGRE Study Committee C2 on power system operation and the SIGRE Study Committee C5 on electricity markets and regulation. Welcome, Suniji. Next, we have Mr. Ajay Bharadwaj. Mr. Ajay Bharadwaj is President, New Business at Renew. He is an alumnus of IIT Roorkee 1983 batch. He started his career with NTPC and Power Grid and worked on initial few projects of HVDC in Indian Grid. He has worked on designing, engineering of several HVDC projects and also operation and maintenance of the same for over 20 years now. He has also worked in various leadership capacities in public and private enterprises, including manufacturing, utilities, and consultancy firms. Since the last 8 years, he has been working in renewable energy sector with special emphasis on renewable projects integration with state and national grids. Welcome, Mr. Bharadwaj. Thank you for joining. Next, we have Mr. Devi Prasad Dash. Devi Prasad is currently working as Executive Director, India Energy Storage Alliance, known as IESA, at Customized Energy Solutions. He has been involved in techno-commercial feasibility, strategy formulation, and consulting in emerging technology areas like energy storage, advanced battery, renewable integration, green hydrogen, smart grid, electric vehicle infrastructure, and microgrids. He is also involved in policy recommendations for the energy storage and EV roadmap for India, manufacturing policy for advanced energy storage technologies, and development of ancillary markets and green hydrogen roadmap for India. Mr. Dash has over a decade of industry experience and part of other industry associations like IEEE, IEEE Smart Grid Working Group, Power and Energy Society, etc. Mr. Dash holds an MBA degree in finance from Symbiosis International University and post-graduation diploma in renewable energy from Terry University. Welcome, Mr. Dash. Thank you for joining. Right, so with this eminent list of our speakers for this panel, I'm sure we'll have engaging session for next 45 minutes to an hour or so. Now, before I go to the panelists, I would like to set the context. I'll just try to set the context first. Now, we have been hearing about this, that we have set a target of having more than 50% energy, electrical energy production through non-fossil fuels by 2030. And that easily gets translated to 500 gigawatts of renewable generation capacity building. And when we talk about that, question comes to our mind that today we are standing at the level of 175 gigawatts. That includes hydro as well. And in the last year, we added somewhere around 15 gigawatts of renewables. Now, if we go on adding renewables at this rate, then by 2030, we should be reaching somewhere around 300 gigawatts. Where do we get these 200 gigawatts from? So we need to have exceptional ramping initiative so long as renewable installed capacity is concerned. How do we go about doing it? Because the latest estimate by CEA, a committee set up by CEA, says that the money required to do so would be of the order of 2.5 lakh crore rupees. Naturally, the government as well as private participation has to be there. How do we bring money? How do we encourage the private participation in the sector? These are the questions. And it's not only about setting up or installing the renewable plants at utility scale or maybe at DR level itself. But then operation of the same, when we integrate this into the system, the operation of these renewables, which are variable and uncertain, is a big challenge. So there has to be a certain set of mechanisms ready with the system operator, and those mechanisms need not necessarily be at the utility level, transmission level. A great compensatory response might as well come from the distribution level. So how do we really get this? What is the role of storage? What are the commercial mechanisms? Is there any scope for having a market structure? These are the questions that come to our mind when we talk about 2030 target. And encompassing all these issues is the regulatory intervention or the policy guidance, policy and the regulatory intervention. How does regulator see at all this? How does regulator develop organizational or plans to have organizational ecosystem in place so that all this is achieved? So these are the pertinent questions that come to our mind. And in this session, we will be talking about that. Now, as all of you know, this is a very big canvas. We have to, we just can't simply cover each and every aspect of this canvas. But in order to channelize the discussion, what we have done is, we'll do is, we'll separate out the utility side, utility scale RE integration. We'll start with that. Then next we will talk about, I will be asking questions to our esteemed panelists about how do they look at the DERs, that is the distribution side of the story. And then I would also personally, and on behalf of every conventional power engineer, I would also like to know about the future of conventional resources that we have. So that would be another important set of question segment that I would be asking. And towards the end, we'll just sum up about what has been discussed. And after that, we'll have an opportunity to interact with panelists through QA session. So I'll start right away. As I said, I will start with the discussion on utility scale RE projects. My first question is to Mr. Ajay Bharadwaj. So, and this question is about project viability through private participation. What are the considerations and concerns of private players so long as investments into this sector is concerned? What does private players take on planning? And it will be nice if you could tell us about the planning phase of utility scale projects and what ideally a private entity would want so long as planning of the projects is concerned. Mr. Bharadwaj, please.
Thank you, Professor Abhyankar, and I'm so pleased to be here. It's a bit intimidating sitting next to all these learned gentlemen, but I'll try my best because I know all of you on my side. So, first question, which the opening sentence of Professor Abhyankar was very interesting, that how do we go from here to there and what are the execution challenges and what is the kind of environment which is necessary to facilitate all of this. Before I say anything, I must acknowledge straight away that I have now spent almost 40 years in power sector, and mostly I worked in power system. But the amount of proactive action I have seen on the policy side, on the rule-making side, on the structural side by the Ministry of Power and Ministry of Renewable Energy is absolutely unprecedented. I mean, I have never ever seen such beautiful communication between the industry, academia, and the government, wherein the dialogue is two-way. Many times they come out with policies where the industry gives a feedback, and then immediately we see that people in a proactive manner are making changes. So that's my first point, that in order to achieve a goal of this scale, the first thing is that the government, who is the key enabler for infrastructure projects, there should be a complete willingness and 100% support from them. And they have, that entity has demonstrated it ample number of times, be it talking to distribution companies, manufacturers, bankers, regulators, finance ministry, legal ministry, forest ministry. Everywhere we have found that that has been a very positive environment has been created. So all of you who wish to develop your careers in power sector, I think that's a very good news for you, because unfortunately in last few years for conventional power sector, particularly generation, there has not been very positive discussion. Now the second question is that any developer, and more than the developer, his banker, his backer, his equity investor is looking for a consistency and the predictability of the policy. And again, I will say that our regulatory framework is one of the finest in the world. The TSA, the Transmission Service Agreement, the PPA which we signed with our regulators is one of the strongest in the world. I have seen it in Brazil, I have seen it in so many other countries, and I can tell you that it is a very, very decent document which addresses all practical issues. And you see, particularly I'm more into transmission, so I can tell you, or even for that matter, if you see generation also, there has been hardly any dispute in terms of people going back on the agreement. Of course, there are always certain overruns, certain clarifications which are necessary, which is in a complex world like the power sector in India, it's a continuous process. So that is another necessity where we need. Now coming to the execution problem. See, by nature, if you see, wind energy is only in 7-8 states of the country. And out of that also today 3 or 4 are the only one which are left with decent enough wind and space where somebody can go and put up a wind power plant. If you come to a solar plant, the viable sites are even more limited. Then if you come out with a bidding process, which is purely decided on the basis of lowest tariff quoted, you are pushing all the developers to converge onto a single location. Because obviously, if in my generation project, in my cost, the biggest element is resource adequacy. How fast is the wind, how frequent is the wind, how much is the solar radiation and things like that. So as a result, what is happening? Everybody first rushed towards Tamil Nadu, then for wind, then everybody rushed towards Gujarat. Now everybody is rushing towards Karnataka. Now, please understand, we are young people and everybody is talking about ESG. We have to understand very clearly that if on a small piece of land, today you go to North Karnataka. In North Karnataka, in 4 districts, today more than 5,000 megawatt is being developed. And commensurate transmission line, commensurate 33 kV network, 220 kV network, everything is coming out. Think about that farmer. How he's going to react when he's being chased by half a dozen developers day in and day out. Please give your land to me, let me build a transmission line on your land. And as a result, what is happening with everybody having a good intention? Developer has a good intention, contractor has a good intention, farmer doesn't want to stop your work, but still, in spite of all that, we are coming across humongous amount of resistance from the local people, especially when it comes to building transmission lines or 33 kV. This, if you pick up the record of last few years, you will find there has been a consistently 5-7 years lag between what has been forecasted by the plan and what is actually is done on the ground, whether it is new capacity additions or whether it is commensurate transmission network. And reason for that is that we are increasingly in an exponential manner are seeing resistance, and this is happening because all of us go to the same place at the same time. Today, if you see, everybody is in Rajasthan to do the solar projects. So my suggestion to planners will be that, like people are thinking in terms of wind, if we can somehow develop a procurement process, a bidding process, which can, which can distribute these developers over a larger piece of area, so that the onslaught on the natural resources, it is not only a piece of land, it's a question of water resources there, road and access and people, all that is graded. It is gradual in the manner, and once that happens, cost will be lower, execution time schedules will be lower, tariffs will be lower, bankers will be happier, investors will be happier, and more money will come in the sector. Very quickly touching upon the issue of what is behind, how to do it behind the meter, DER, distributed if you see generation. I personally feel I'm extremely excited about the next 10, 12 years of what is going to happen in our country, practically in every single sector. We are very fortunate that our renewable revolution is happening at a time when our IT sector, our telecom sector is also going through a quantum jump. All of us know 5G is coming through. All of us know that computing is becoming much powerful, much more powerful. We are talking about data centers. Sensors are coming through, and drone technology and rules are in place, whereby your mobility itself is also addressed. I see this as an opportunity to genuinely democratize the power generation and power consumption, especially the renewable energy in India, where every single consumer is also an owner, is also a stakeholder in one manner or the other, and is also the well-wisher of the power system. Any one of you who is studying the power system today would have noticed that our distribution companies suffer from perennial losses because of one of the key reasons for that, apart from so many other reasons, is that customer hesitates to pay, or even customer, even if it is ready to pay, it is not ready to pay you the right tariff. Why? Because there is a deficit of trust. And number two, it is also, he has nothing at stake. He is not looking forward to an improved service if he gives a better. So, right from our planning phase, I think this is a time when 2-3 things, in my personal opinion, should be done. A, planning should recognize, the planner should recognize, including the regulator should recognize, that their behavior hugely influences the cost of project, the time of project in which the projects are built. Because if you suddenly throw thousands of megawatt worth of bids or thousands of kilometers of transmission line among a set of people, all of them going in a particular geography, we have already set people for failure. Even the best contractors cannot succeed later on because people are people. So other thing is, one thing is that in our planning, can we develop a sort of more sophisticated, maybe buzzword called artificial intelligence based techno-economic model with customer in the center. And I am not saying customer as a cohort, but customer as an individual, what you see on an e-commerce site where n is equal to 1. With that customer in mind, if we then see the entire value chain, that from my solar plant to this customer, how power reaches and how much is it really costing him, and how much is it costing to the society. If somehow we can develop that model, I feel it will go a long way in accelerating this capacity addition program, and we will be able to achieve this 500 gigawatt goal in a much happier manner. So behind the meter also, other issue I want to address here is, if you want a common man to take interest in renewable, if you want him to invest his hard-earned money in a solar panel or in a wind turbine or in a biomass or in whatever it is, you have to convince him that his money put together will give him a return for next 25 years or 30 years. Because if you are only giving him subsidy, it is not sustainable over a long term. Now, how do you give him that confidence? You have to give them a confidence by creating maybe a microgrid or mini grid based integrated system which has solar, wind, storage, maybe hydrogen generation, maybe hydrogen fuel cells, vehicle charging system, and everything put together, where in that ecosystem he is one of the players. This will ensure that the money comes, resources come to this investment, the common person becomes a stakeholder, he doesn't see it as a nuisance, and it's a sort of becomes a mass movement where you don't need to convince people. People will, if people make money, if they can earn 10%, 12%, 13% return on their money and can also get free power, why not? As long as they are with smart people like who are sitting here, they have developed a plan for them and they have proven track record. Their word is trusted by the bankers. Their plan is trusted by the transmission companies. These are the people who have to come and help the common man today. Because in this country, we have to involve them, because the health of our distribution sector will ultimately decide that what's the future of the entire power sector. So I think, I don't know how much time I have taken. Maybe I've exceeded. This is what I wanted.
Yeah, so there's one.
Yeah, just last
Sure,
point.
sure.
Yeah.
Yeah.
Last point about the conventional power plant.
I'll come to that part a little later.
Okay.
I have one more question, but not now for you. This is related to behind the meter kind of a scheme. I'll just ask at a opportunity.
Thank you so much.
Thank you, Mr. Bharadwaj. My next question is to Mr. Soni. Now, whenever we talk about 2030 target, we talk about adding renewable capacity, generation capacity. But then the transmission system or the delivery of electrical commodities at the doorstep is equally important. And when you talk about that, equally important is the flexibility issue. So we would like to hear from you, Mr. Soni, about grid operation and the importance of flexibility and the importance of transmission.
Thank you, Renew Power. Hello. Yeah, sorry. Hello. Can you hear me? So, thank you, Renew Power. Thank you.
Sir, you will
Yeah?
have to hold it like this.
Okay. Okay. So, thank you, organizers. Thank you, Renew. Thank you, chair, session chair. Thank you, my co-panelists and the students and the professors in the hall. I would say that it's a God-sent opportunity. People say that renewables is a problem, it's a challenge, but there cannot be a better opportunity than this. And I'm not repeating all what I have myself seen, the amount of trauma and all the ash contents near a thermal power plant and the daily chorus of everything being done by hand. I've seen my grandmothers doing this. How many people fallen sick because of all such things? When you look back, then you find that what we are doing is for our next generation. All these things which you are talking about is too small a thing, thinking of giving good, that's what the climate issue is all about. So, coming to the topic, all what we could not do, which we wanted to do in power system, in the name of renewable, Now I find it easier to do. Many things were required even earlier. Before the renewables came, also they were equally essential. But they were not getting attention. But now they are all getting done. So that's the positive side of it. The other aspect, if you look at that little bit of SWOT analysis also, there are threats, there are uncertainties, there is unknown. You don't know what kind of a technology will come. That challenge has come. It's now no more a set thing of 210 megawatt set, like a photocopy, you keep on putting 210 megawatt. It's not like that. It's really a challenge. But then, here lies the opportunity. Here lies the opportunity. So the wish list is a big long laundry list. It is not one or two things we have to do. We have to do many things to, get really large scale renewable, integrate them well in a secure fashion, economics and all such things. But the 2 points which Professor Abhyankar flagged, let me deal with that. So all of us, all those who are sitting here love renewables. There is no doubt about it. I don't think anybody says that I don't love renewables. But if you love renewables, you must love transmission. Number one solution, numero uno solution. And that is where India has really done well from all sides, from policy, regulatory, procurement, competitive, right of way issues, and the whole world is watching India, that how come you have such a strong national grid, and through that we are able to integrate renewables. Now renewable has come on the spotlight, it is there on the radar of everyone. But our visionary policymakers and the regulators and the industries, they started building transmission much earlier. So there is something which I can keep on talking about, but I would say that a country where all the dozens of HVDCs are controlled from one place, a country where you can have 15-minute power from anywhere to anywhere, we are able to construct solar parks and wind farms of such a large ultra mega size. It gives tremendous amount of satisfaction, and it's something which has been achieved not by one or two but hundreds of people who had the vision of doing this. So I would say that we must keep doing. Now this was from the grid side, and of course now we will talk about from the distribution side. And equally is the rooftop generation coming up, and that's a big challenge. Whatever I learned, I have to unlearn. Our idea was very simple, power flows in one direction, but now it's in the reverse direction. Protection is an issue, hundreds and odd issues, safety is an issue, everything is an issue, but that's where lies the opportunity also. The next point which you mentioned by Professor Abhyankar is flexibility. This is one key word which I realize that it is equally important in life. Now the yoga teacher in the morning tells, are you flexible? I said, yes, I am flexible. The moment he asks me to put my hand in the back of the, then I find, okay, this part is not flexible. So every part has to be flexible. It's not very easy to do. And only when really thing is required, then you see whether he is flexible or not. So whether generation flexibility, generation thermal flexibility, hydro, even nuclear, we are asking them, why can't you, flex at least with a good notice. Transmission also a lot of flexibility we are trying to introduce. Demand flexibility, a big area. Why only everything from supply side? Why intermittency has to be matched with the generation flexibility? The demand flexibility. There is an ancillary service regulation says about demand response. So that's the flexibility in the market design. Flexibility in the operation, everywhere flexibility is the key word. So on that also I would say we are doing a lot of work, and in 2014 when there was a sudden announcement of 175 gigawatt, everybody was saying that how will you do it, how you have arrived at 175, this was the question. Then we said that, well, policymakers are policymakers. They have given us a target of 175. We will all work towards that. Not that it's an engineering problem. Policies are not engineering problem. Engineering has to work towards the policy. That is something which I would try to say everything, that all the time engineering has to achieve what you want to achieve. And then we started doing simulation, modeling, so many regulations, and today we have achieved it. I myself get surprised that, oh, given 175 target and we are almost there. So now 500 gigawatts. So the bar is being raised, but then that it will become more challenging also. There is no doubt about it. So the other two things are, if you want economy, everything is good, but one thing will always remain, sasta chahiye. So, economy, if you have to achieve, you have to have market. And market is very cruel. Market is not very easy. How public will respond. The Dr. Chatterjee has to see how the regulation comes and next day people behave in a different fashion. So when we say renewables, how do we make it economical? See, otherwise everybody knows that renewable is good. Everybody knows battery is good. But whether I can afford or not, that's the question before us. And so many regulations are coming up. Everybody has understood all India level market, day-ahead market, real-time market, and it's not a small quantum. Thousands of megawatts are getting traded. So that's also an excellent thing. But then the situation is becoming tougher as the penetration of renewable is increasing. Inertia is an issue. Inverters are an issue. Low voltage right through, high voltage right through, harmonics, I mean, name it. And all those who are working on inverters, then I envy you. You have so much to do, so much to, even retrofitting of inverter will become a job by itself. So much of work is required in the area. And reactive power. See, we were used to our large machines, they will give us inertia and reactive power. Now we need reactive power from passive generation also. I would succinctly put it like this, long story short, now renewable is no more a kid. We have supported it. Now it has become full-fledged adult. So throw the kid's glove out. Demand from renewable everything what a conventional generation would give, plus something. Because you are electronic, you are fast, and why not? We should be able to do it. We can't hide ourselves, and that's how the industry is also coming up. All kinds of controls are being brought in, and renewables are doing almost everything what others. Of course, there are associated issues. We need to introduce more instruments by which they help. For example, we need aggregator so that they can make advantage of diversity. So a lot of scope is there in the country as far as the large scale renewables are concerned, and low probability, high impact event. That is the problem. 95%, 97% of the time, it's not a problem. It is only that 1 or 2% time that something would happen, and that we have to take care of. And for that, a lot of investment is required. So I would stop here, but I would leave a thought to you all that numbers are changing. The old people like me, we are all used to 80%, not less than 90% PLF, everything, line utilization has to be 80%, all such things. Now this needs totally reverse. Totally reversed. How it is like this, in our younger age, how much you can eat, that was the competition in a feast. And now I find my children having reverse competition, how less you can eat. So now what is the utilization factor of renewables? Very low. Capacity utilization 20-25%. Capacity credit even less utilization. What is the utilization factor of transmission? Any numbers? No. 20%, 25%. So all those days of very high numbers are gone. We have to completely reset that and come out with new indices and new thing, and nothing to feel very shy, apologetic or defensive about it. Things are changing. We need to write our new regulation. Let me stop and listen to the other experts.
So, Mr. Soni, so the key message regarding flexibility that I picked up from your talk is that beyond a certain point, we should stop treating renewables as different kind of resource. We should start treating them. We should start demanding from them what we demand from our conventional generators. Is this what you're trying to say?
Well, I'm saying that
Because that involves technology, innovation and all that.
so, then for anything which happens for a child, in the initial stage you support, you have given all kinds of concessions, SOPs. It's all fine because technology readiness level and all such things happens. But now that it has reached, even now also telling that you will get this concession and you will get that concession, grid inertia will be handled by somebody else, reactive power will do somebody else, and you will under fault automatically trip. That cannot work because up to 4%, 5%, nobody bothered. Okay, one small 20 megawatt of wind turbine or 100 megawatt or somewhere we are able to accommodate. But now when you have thousands of megawatt of solar park, and suddenly because of a fault the entire generation will go out, then the grid security is under danger. So they have to take care of this. So what I'm saying, and see, one of the regrets I have is the nuclear. For example, nuclear still does not come on our table for discussion. That has to be brought on the table. We understand the technology, but it is not a small modular reactor, or how can you make it flexible? Something has to happen. So now renewable has started coming on the table. They are discussing. They are saying what is your problem, how we can help. Standards and other regulations are getting tightened, and they are responding. I'm sure Dr. Chatterjee will explain all these things. What renewables initially used to say that we can't do anything. Whatever will happen, you have to accept. We can't forecast, we can't control. That will not do. But today, with all this forecasting, things have fallen in place. People are doing much better. IMD has changed. Look at the IMD website. We only said that if you want to have such a renewable, IMD has to change. And I think IIT Delhi has done a lot of work on the forecasting front. Fantastic. What we could not think, now it's happening. So all what I'm saying is that there is a potential there also. And that has to be, they have to be challenged. And for that we need research, we need deployment, and it's all doable. That's my firm belief. But one has to challenge. One cannot keep on pampering something beyond a point. That's the point. Thank you.
Sure. Thank you so much. Thank you so much. So when we talk about flexibility, invariably we start talking about the utility scale batteries, or the battery storage, or any storage for that matter, which can do, which has got practically very high ramp rates. So my next question is to Mr. Dash. And this is about utility scale deployment of battery storage. So I would like to hear your views on this, whether it is feasible. I'm talking from Indian perspective, and naturally I'm talking from the cost point of view of the current technology that we have, so long as deployment of the same at utility level is concerned. And if you could shed some light on economics and the policy framework for utility scale battery storage.
Okay, so thanks everyone being part of this discussion. So specific to battery storage, or because I will not only talk about battery storage, I will use the word energy storage, which includes maybe pumped hydro, mechanical storage, and all other form of storage. In the electricity value chain, this renewable is not only creating problem on the generation side, from generation to transmission to distribution, and also to the consumer some part, it is creating challenge. The question is that sir mentioned, Soni sir, we have to accept it and we have to address it. So talking about on generation side now, it may be any form, it may be RTC way or it may be peak power way. Multiple tenders are coming to address and giving the firm power output to the grid. That's one part. Other part is about to address the peak of the generation of the solar. It maybe looks like a bell curve, but if you go for a second by second data, it's not really a bell curve. And third part about this generation, how it is matching to the demand, that I will come to the later. So this is one way, and the hybrid may be the other way, which can address multiple generations at the same time. It may be solar, wind, and storage. And second part is about the transmission. With generation of the wind and solar, at some point of time, you have a transmission congestion. Other point of time, your transmission lines don't have the energy to supply. So that's a problem will continue or will increase over the time. Giving few examples of Tamil Nadu or other high wind states, they forced to stop few of the plants due to the transmission congestion. That need to be addressed. So there is the storage can work. Third part about the DISCOMs. Yes, we have limited private DISCOMs who have already taken their first step to manage the peak load in the evening or managing the peak demand in the few localities like Bandra Kurla complex or similarly in Delhi and other locations. You need a storage at substation level or stations level, at distribution level, and few projects has been running in India. We are not able to monitor it in properly, how it is impacting, that's need to be monitored. But we need storage across the electricity value chain, that's first part. Second part, just telling about it is not only about renewable, we have to go beyond talking about base load. As globally, now there is no base load. It is about, it's about matching the demand and supply. So it's about which are the generations are supplying the energy and power and which are the loads. Just 1 month back, I attended one of the forums addressed by PM. Honorable PM mentioned about 6 crore electric cookers. Just consider, this is another load coming to the grid which will be used mostly by households in the morning, which is again a peak load. After 9 o'clock, 10 o'clock, everyone leave to office, the students will go to school, and 6 crore electric cookers. So it's considered about all type of new loads which is coming to the grid. It may be electric cooker, it may be behavior of charging of the electric infrastructure. Grid is not the same what we discussed 10 years back. The grid is different now. The load is changing. Our generation is different. Generation is not giving out 24-hour supply. Maybe it kicks off at 9 o'clock, kicks down at the 6 o'clock. We need the plants, the plant which need to be flexible to ramp up at morning 9 o'clock, again ramp down at the 6 o'clock. So we had a great presentation by Narasimhan sir from Grid India. Just 1 week back I had a discussion. He's telling about how the duck curve in the mid of the day in India currently is actually expanding. So that's the issue we are facing. So this is about why we required maybe storage is one of the solutions. We have to demand response program or DSM program. If you run successfully, then maybe storage requirement might go down, but recently CA is also mentioned about 250 gigawatt hour of storage on the battery side, 18 gigawatt hour on the pumped hydro side. So we know the need. Now let's talk about the policies, then we'll talk about the economics. So on the policy side, it taken long time, but now we have announced about viability gap funding. It's an initial kickoff. It may not be there for next 5 to 10 years to go for the, as sir mentioned, renewable, when there was few initial schemes or support system, like viability gap funding is one of them. There is now state level SPOs are coming, storage purchase obligations. So it is, so it will be now state level, the DISCOMs or states need to have the storage as in the part of their electricity value chain. This is another policy. Similarly, draft energy storage policy, which is developed by MOP, that will be implemented soon. And so policies are coming both on, I'm not mentioning about manufacturing policies or now just focusing on the deployment side. It took time. Few of the outdated policies are still there. We may get in some time, but it is in positive direction. That's the second about the policy. Third about the economics. So when we compare, so it's about the economics with what you are comparing. So the levelized cost of energy from a single storage asset, are we comparing an island like Lakshadweep or Andaman Nicobar? Then storage is giving you at 15 rupees and you are comparing with 38 rupees of diesel genset. Are we comparing in Gujarat with a combined gas cycle plant, which is at storage at 15 rupees and the combined gas cycle plant is giving at 25 to 26 rupees. So with what you are comparing, that's or what you are eliminating. So for a black start application, instead of a combined gas cycle plant, storage is a better option. And again, about independently storage LCOE, if you'll consider, then you may not have a commercial feasible project. If you are integrating with a renewable might have a 2 rupees LCOE and storage has a 8 to 10 rupees. Then combinedly because if you are having a 100 megawatt hour plant, your storage may not require 100 megawatt hour. The project designer need to design the plant to address the maximum challenges. It may be globally 20% or 30%. If you have a 100 megawatt project and 20 megawatt hour energy storage systems, then you may have a lower LCOE, which is 4 to 5 rupees. So that's you are comparing. Again, when you are comparing, what value you are adding? When you have a renewable flow storage, you are addressing what are the value capture you are doing. Is that project is capturing the value which is eliminating one of the conventional plant? Second one, is it supplying to the grid and managing the grid frequency? Third, is it have an option to supply to the behind the meter applications? Fourth, so we have to think that what are the benefits this combined asset is giving and how it is eliminating the other cost. So if there is multiple reactive power is coming, storage independently is dead. It needs a power electronic system. So there is a policy might come up from MOP giving incentive on the power electronics. So when you have a 50% of power electronics, like you have a balance of the system includes inverter again, you have a BMS, EMS, you have a controller, you also have a PCS. So this power electronic system which is used for storage is also capable to address your other issues, maybe not 100%, but many of the issues like harmonics, reactive power can be managed or can be controlled through this power electronics. So you have to consider as a holistic system of the grid what it is addressing the value. That's about the economics. And last but not the least, this storage, when we talked about in grid scale, you consider about like how we can combine the storage systems in the consumer side, create a virtual power plant, or the electric vehicle which are running in the fleet type, how they can combine and respond to the grid. It's not about always creating a new project. You have to find a business model how this asset which is using the energy storage in any form. It may be a pumped hydro for grid stability, mechanical storage for the ancillary which is now allowing storage. So you have to find out in what assets you are using and maximizing their revenue by managing the grid, because the grid is totally new. If you talk about 10 years grid and expecting a base load supplied by the conventional energy, we are actually far behind than the advanced countries. So we have to respond to the new consumer profiles which is coming in now work from home. That's how actually last 2 years the load profile is totally different. So we have to be think about the newer profile loads, and yes, many of the states and central government authorities understand it, and they are very much proactively actually responding and creating the policies, which is very positive in last 2-3 years what we see. And if that will go, we'll have a electricity market is similar to one of the interesting market to understand. And there you will find players like integrators, developers, technology players. So it will be an interesting market.
Sure, thank you so much. Thanks a lot. My next question is to Dr. Chatterjee. Now I'm going to the other side of the spectrum as well. So Dr. Chatterjee, my question has two aspects. One is the utility scale projects, and the other is, of course, the behind the meter kind of TERs. Now, as I mentioned earlier, that an organizational ecosystem has to be in place in order to make these utility scale projects success. So what could be possible regulatory intervention, or even from the policy point of view, how do you say this? What could be interventions from the regulatory side to make utility scale projects a success? I'll just give an example. So when this renewable started coming in, CERC waived off the transmission prices for the renewable generator. similarly, if you could cite a few examples and what could be, possible such interventions, that's number one. And for behind the meter DERs, various states, they have different regulations, and the regulations could be altogether, the grid codes are altogether different. Do you see that there should be a common thread adopted by all the states so that a common framework exists to promote the behind the meter DERs?
Thank you at the outset to IIT Delhi and the organizers for inviting me. Let me challenge myself to see if I can enlist the attention of this audience at this hour, and that too on a dry subject like regulations, especially dry for this audience, because we have been talking about engineering and all that. Regulation possibly would be a new thing for most of them sitting here, but just to give a perspective, as policymakers and regulators, we are also evolving as the sector is evolving. So way back in 2010, for the first time, I'm first trying to focus on the large scale and then possibly would come to the DERs. So in 2010, we had the National Solar Mission, when first target set by the government was 20 gigawatt of solar, and we were scratching our head at that time. I mean, what nonsense is the minister talking about in terms of 20 gigawatt? I still remember. So then came 175 and now 450 gigawatt and 500 non-fossil fuel. So now these numbers don't frighten us. So as I said, the sector is evolving, the policymakers are evolving, so are the regulators, and so are the regulations. So some of the, I mean, one example that you mentioned about free SOBS transmission waiver, of course, it was the CERC which initiated that. That was one kind of a thing. Later on, now it has been taken over by the Ministry of Power, and a lot of policy pronouncements in terms of extending waiver. But I would like to, I mean, broadly give an idea about what this regulatory ecosystem is as enablers, how it is seeking to act as enablers to RE integration. That would possibly set the tone and also set the context for all of us to appreciate the discussion on this topic. I mean, you may have investment, but once you are, you have made investment and set up a project, the first thing that you need is connectivity to the grid. Once you are connected, you need access into the transmission system to sell your output to a buyer. Once you sell your output, the network that you are using to sell your output will have a cost to be paid by someone. So we call it, and then, so all these are so interlinked, and we understand this in the context of the regulation. So we need a regulatory framework which defines the rules of the game for connectivity, for access, for transmission pricing. These are the three important components. Whenever you talk in terms of the large scale RE integration, you should have absolute, and as I said, we are also evolving in terms of our regulations on these three critical elements on connectivity. I mean, if you have a look at the, we started with connectivity regulations in 2009, brought about several amendments, either through amendments in the regulations or in the procedures. And most of those amendments and changes were in the wake of large-scale RE integration, because, you know, and it's, I mean, in the recent past, I was in US as part of the Fulbright Fellowship, and I discovered that India has done so much which they are wanting to learn from on the transmission side, to be very honest. I mean, I had 2 full months whirlwind tour to interact with the academicians there, practitioners there. All of them are clueless about how, because they also have huge, interconnection queues for their wind generators and the solar generators. So their only question that, that India is moving this fast on the renewable front, how is it resolved? Are these issues there? And how is it that India is resolving these issues? As regulators, we are working on it, and as I said, we came up with a separate set of regulations only to deal with the, what we called squatting issue. Squatters, because, quite happened, the important point that was highlighted, that, connectivity was initially was free. Anybody could get connectivity to the interstate transmission network without a cost. So it's like putting your, handkerchief. So you don't know whether you'd win the election, win the competitive bidding, because off late the trend of project development through bidding has started. So whether you win or not, you have already applied for connectivity and you are in the queue. Those who are winning the bid are not there in the queue. So this issue of squatting came. We came up with some solutions in terms of stage 1, stage 2. Not getting into all those details, but these are issues which need to be resolved for making grid integration, large-scale grid integration a success. Once you are connected, you would need an access right to the transmission system. So we have evolved over a period of time in terms of access rights. And in fact, I did deliver a talk there. How India, especially how in India we have evolved this with this whole process of access. We started with different forms of access called long-term access, short-term access, medium-term access. Now we are talking in terms of the general network access. So access rights, they have been talking in terms of financial transmissions, right, FTRs. We have not yet moved to that. We have physical transmission rights, and we have such detailed rules of the game for general network access. Third, transmission size pricing. If you are using the network, you need to pay. And who better than Dr. Abhyankar, who was himself involved in the initial phase in terms of transmission pricing. There also we are evolving. We started with a postage stamp method, then went on to a POC mechanism. Now it's a completely new scheme of transmission cost allocation, which is what we call sharing of transmission charges and losses, which is primarily based on the access, the total access that you have. Largely, if I put it in a very simple language, the current pricing framework is that 80% of the transmission cost would be recovered based on the quantum of access rights, transmission access rights that you have, and about 20% would be based on your usage. Absolute clarity, and that was what was explained, and they're still, the West is still trying to grapple with this issue. So anything that you talk in terms of the connectivity, access, and transmission. So this is the kind of role that a regulator plays in terms of integration. That's on the one side. But once you have done that, another important and critical element that is required is the market design issue and the balancing and settlement mechanism. This is also an important contribution of the regulator in this whole scheme of RE integration that we are talking about. It's not enough for you to have connectivity, have access, and have clarity in terms of the kind of transmission price that you pay. Now you have to go and participate in the market. So what kind of market platform do you have? Do you continue to engage in a long-term power purchase agreement with a buyer traditionally as you are doing? Or can you have an electronic platform like the Power Exchange, where either on a day-ahead basis or on a longer duration basis you can go compete with other generators and participate and see. So we created since 2008, we have been experimenting with various products in the market. In the talk about day-ahead market, there was a missing link, in the entire market design. We did not have real-time market. After day-ahead market, people depended on unscheduled interchange to meet their energy imbalance. We created a very closer to a real-time market, where we said, no, please, if you'll always have imbalances, energy imbalances, because D-1 is too long a period to project either with firmness, generation, or demand. So you need to correct your position. So here is a platform. Go use that platform, go in an organized manner. So we created that platform. We tried to cater to the needs of renewable, created a separate market segment called the green day-ahead market. And then there are a lot of issues that go with it. And now possibly we are trying to show to the renewables that, this is also, this kind of a market structure also can give you an answer to many of the questions which you are trying to get answer based on certain, SOPs. Like you give me free error deviation, no charges on me. I mean, one message which is coming is like, here is a platform. You can go and participate in the day-ahead market, correct your imbalances in the real-time market, because at least 1 hour ahead, which is the hourly market, and we are trying to shorten the real-time market duration as we go along. So at least one hour ahead, you will be able to project with certainty. So you can start with D-1, then correct your position, and then you don't need to really depend on, and then you can, these things also will encourage you to go with your storage. You can think of becoming more and more firm, as Mr. Suni rightly said, that things have come when you explore all these opportunities. You can easily, with these kinds of market structure, you don't need to depend traditionally on SOPs. You don't need to beg for your existence. You have to legitimize your existence based on, innovative and technological advancements. And I'll talk about the last important point, which as a regulator, we have an important role to play, and we are trying to work on, is the balancing requirement and the flexibility, the point that you're talking about. The system has to be flexible. We have created a regulatory framework where, we are as a country evolving from a cost plus regulated regime to a market-based regime. But flexibility is one, and here also we are evolving. We have different models of market-based flexibility framework, which has worked in some but failed miserably in several advanced markets. So what we are trying to do is, create an administered mode, at least in the transition, where we are saying that here is a regulatory framework. Today, you cannot expect, as rightly pointed out by Mr. Suni, you will not be able to achieve 85% the conventional. You'll have to go down to give entry to the renewable. So we created a framework. But if you are coming down from 85 to 55, which is the technical minimum, you need to be compensated. There are hard costs, so if you, one is that you let them go into the market and recover their costs for coming down from 85 to 55, and now we are talking about 40%. The other is you create some sort of an incentive, disincentive mechanism within the existing framework, so that at least you can harness whatever is your existing system in the existing thing. And the link to this is the ancillary services market. You can imagine a power system as big as India has been working without AGC system. We did not have secondary reserves, or did not have that. Now we have started talking in terms of a regulatory framework for primary, regulatory framework for secondary, regulatory framework for tertiary. So that's in brief in terms of the overall regulatory perspective on the large scale RE integration. I'll take 2 more minutes on the behind the meter, or the DERs. DERs, of course, is a subject which is still being debated. And as of now, we have not seen large scale proliferation of the rooftop. But as you rightly said, we already have, a forum of regulators which does a unifying job, and we have created some sort of a model guidelines and a regulation for rooftop, and especially, some of the techno and commercial issues we have tried to address through those model regulations. Say, for instance, there are issues about what is the maximum load that you can have on your rooftop. So, like, say, you cannot have possibly a rooftop more than 90% of the connected load that you have. Then linked to that is the loading in the distribution transformer to which you are connected. So there would be a link to that. And then there are issues about net metering and gross metering, which are commercial in nature. But we have defined the rules of the game, because there are DISCOM's health issue as well. Because if you, given the current declining trend of prices of solar, net metering no longer makes sense, especially for distribution. So we are talking in terms of a mix of gross metering and net metering, gross metering where you have two separate streams. So that's one way of doing that. And the behind the meter or the DERs, we are, at least even from center, we are trying to lay a lot of emphasis on the demand response. For the first time on lexicons, you will find the demand response mentioned in the regulations of CERC, in the ancillary services regulations, now in the new grid code which is coming, likely to come within a month's time. You will find we are creating a framework for demand response. It will take time before that comes, but that is going to give you the greatest flexible resource to be able to integrate. I'll stop here, in the interest of time.
Perfect. Thank you so much. In fact, I was just about to ask the panelists about the potential that we have so long as flexibility of loads is concerned. So my next question is to Mr. Suni and Mr. Bharadwaj, and this is about flexibility embedded into the loads. Now, the entire Western world is talking about, or they are, kind of dependent. They say that whatever is the compensatory mechanism or compensation, when we have large-scale renewable penetration, it would come from the demand side. The loads will take care of it, and they are very pretty sure about it. We of late, have started discussing about the load flexibility, but then in the Indian context, should we lay equal amount of stress on the load flexibility? What is your opinion? And this question is to Mr. Suni and then to Mr. Bharadwaj.
So, thank you. So let me, recall my experience as a student and map it on to the flexibility and the regulations and all that. So in Kharagpur Gymkhana, we had an instructor who was also a physics teacher. So he would say cycle race. Write down the equation of cycle race. In minimum time, maximum distance has to be traveled. What are the techniques? Throw your weight in front, paddle fast, and all of us know cycle race. One day he came like a regulator and suddenly said, reverse the equation. So what is that equation is reversed? In maximum time, minimum distance has to be covered. But students are students, very intelligent. Within seconds, people realize that he is talking about slow race. So in the slow race, people excel to the extent that the cycle was steady, standing and balancing, and excellent thing. Then he found that yes, these students have learned this. Then he said, now let me ratchet it up. When I will give one whistle, equation 1 has to be followed. When I will give 2 whistles, you have to follow the second equation. Now the question was, most of us failed during the changeovers. If you are in the fast race, you are good at it. You are in the slow race, you are good at it. But sometimes slow, sometimes fast. And then he said, this is life. And I realized that this is what we expect from the generators. Ramp up quickly, come down to minimum level, go to maximum level, and all that. But then, for all these things, you need incentive. You have to recognize flexibility, define matrix for it, measure it, pay for it, and incentivize it. Again, on lighter side, one of my mentors, he was a thermal power plant expert. So when we started going down in the thermal generation, we used to say, sir, not possible, boiler in flame instability and all this blah, blah, blah. So he told me, Soni, don't tell me all these things. I have done power plant operation for donkey number of years. If you give me incentive, believe me, I will come to office at the right time doing Sirsasana. And you don't give me incentive, I will have all the excuse. Aaj train late ho gaya, kal jam tha, falana, falana. So give money to the power plant, they will show you what flexibility is. Demand side, huge flexibility. Indians, we are very frugal, very price sensitive people. Give me 30% discount, I don't mind pushing my dinner to 9 p.m. 10 p.m., 10%. So somebody, very senior person said, he said, you give me very high discount, I will skip the meal also. So do you think that demand is not flexible? Who said demand is not flexible? Demand is tremendously flexible. And there is a reason behind it, you know. Everybody is suggesting cure, but find out the cause. Cure mein sabka interest hai because cure is investment, capex, money and all such things. Whereas if you find out the cause, then this why is headache. Yeah. But if you find the cause, then you do it in much cheaper fashion. My question to all the regulators and equipment manufacturers and everything is, I don't have money. I'm a poor country. Give me solution which is cost effective. We understand all the technology. I understand the technology. So that's where the demand response is there. Flexibility is there. Steel plants, they don't mind reducing it. AC plants, what is the problem if you stop the chiller? We know about all those technology, but then you have to pay money. Recently, our regulators have set 50 rupees rate. So 50 rupees, you can go to 50 rupees. You know, April onwards, we will be able to buy 50 rupees power. So I was only telling that give me 50 rupees, I will reduce my load of house. I will work with one bulb. Give me 50 rupees return. So this is not the demand response. And I see a huge potential of demand response in this country. We are adding generation capacity for that kinky load duration curve, all of us know. Last 1% of 1%. Why add that? Go for demand. I stop, sir.
No, perfect. I got my answer. Thank you. Mr. Bharadwaj, please, about load flexibility.
I'll just say a couple of things. I mean, problem can be given to be solved. You know, engineers can solve that problem. But the point is, as Mr. Soni was also saying, engineers are supposed to look at the economics also. The way our generation is coming in one direction and the transmission system is being created which becomes unloaded during the night and requires humongous amount of reactive power support, or the way our load factor is, it is not sustainable to keep making investment in transmission or in distribution network and serve such huge load peaks or cater to such generators which generate only 8 hours or 6 hours in a day, and for 18 hours they require to be supported by the reactive power. So that flexibility is a must. Let me just share with you, in 1983 when the first HVDC project came in this country, two first projects. One was the Vindhyachal HVDC back-to-back project, which was a link between northern and western region, and another was a HVDC bipole which brought 1500 megawatt from Rihand to Dadri. And at that time, Indian grid was very weak. I think sometimes our effective short circuit ratio was barely above 1. It was 1.2, 1.3 in certain places. The requirement on us was to have plus minus zero reactive power exchange with the grid. In case of Vindhyachal HPDC back-to-back, for 500 megawatt plant, the reactive power exchange band was plus minus 25%. And plus minus 25% means if you have imported 25 MVR for some time, then for equal time you have to return also 25 MVR. Now, this was something which could be very well achieved through electronics, as one of my co-panelists was pointing out, by controlling the thyristor firing angles and by having a fixed or little variable capacitor bank and the reactor bank, that huge issue could be addressed. But as they say, the most difficult problem in the world is to change an adult person's behavior. And it is directly dependent upon the triggers, the trigger which you provide. Same is true for the customer also. The same customer will be behaving very differently as long as there is a conducive price mechanism in place where it makes sense for him to shift his load from the peak load time to the off-peak time. I was taking my training in Manitoba, and Manitoba Hydro had a huge program. I am talking of 1987, a huge program to convince their customers to shift their swimming pool heating, their washing machines, their all these various kind of power guzzling gadgets to the off-peak time. While that was a predominantly hydropower state which was generating power at a throwaway price, but they didn't want their customers to develop bad habits. Right from the beginning, they wanted them to push towards flattening the load curve because they knew that beyond a point it will become unsustainable, and the same customer will say, I don't want to pay. So you don't want to change your habit, and you also don't want to pay. So it is like having your cake and eat it too. So both things are not possible.
Sure. Thank you so much. We are running short of time, so I'll stop asking my questions. I have a long list of questions, but then let's open this up for questions from the audience. If you have questions, please raise your hand, introduce yourself, and ask a question. Yes, over here.
Hello, my name is Faizan Khan. I am an alumni of IIT Delhi, Masters in Atmospheric Sciences. So my question is towards the regulatory side. You talked about the real-time market and also on the RE integration, long-term market, like when we are looking at long-term integration. Okay. So first, coming to the real-time market, we have just opened to the real-time market and introduced DSM regulations, right? CRC has introduced DSM regulations where you can update your schedule 1 hour before, which is almost real time. The schedule has recently changed, the DSM regulation has recently changed from 15% error band to 5% error band and 10% error band. Above that, no over injection is allowed. So one part is that the shift in this regulation, even though in terms of forecasting and scheduling, we were not able to achieve even 15%, right? So first is that we have reduced the band. Second, my question is towards Renew Power, which is an IPP, and they are trying to integrate more and more renewables into the grid. But they are doing their PPA on a study on past basis, right? How a site has performed in the past, like 5 years or 10 years. But what about the same resource that they are trying to harness, be it wind or solar, will change in terms of climate change? Like for next 25 years, 30 years, the resource will be different for that zone, for that area where you have put up your power plant and have a PPA for next 25 years. How are you handling that challenge? So
I would be brief. I mean, of course, you have been, you must be following the debate around this free band zone, and I think at least two of us emphasize the need for gearing you up rather to help you to mainstream yourself. You are no longer a kid and you have to behave like a grown-up, and you don't have the liberty to say, I can't achieve this. So this is the message that the regulator wants to give. I mean, there is nothing that is impossible. So you have to look at the history, as I said, when in 2015 we first time introduced the concept of mandatory forecasting and scheduling of wind and solar, we were almost taken behind the bars by your industry. They said, I mean, what nonsense is the regulator talking about? Are they aligned to realities? As regulators, we never come out in the public, and we are always on the receiving side. So we kept on listening and see, people got used to. Now you are saying that, see, 15% was okay. So when in 2015 we were writing the regulation, that was the kind of brickbat that we had to hear. Now 15% to 10% that we have done. Again, so it's all natural, but you have to graduate over a period of time. But in the interregnum, we have, sort of compromised and brought about some changes. We have allowed 10 plus 5 and 15 plus 5 for wind and 10 plus 5 for the solar. But as I said, there is no free lunch, If you want to legitimize your existence in the existing power system, you have to make sure that you don't become a burden for others. Because ultimately, if you are deviating and if it's a free zone, this cost is being borne by someone else. And they are none other than the distribution companies within whose area you will be locating your plant. So they will start creating tariff or non-tariff barriers to make sure that your project does not become viable. So try and always see regulation or a regulator from that perspective, that if you are taking some hard decisions, possibly it is in your interest and not necessarily against your interest. I'll stop here.
Thank you for the question. Yes, it's a very, very difficult problem to forecast wind patterns, specifically over a medium term or even for a short term. And we have been grappling with this problem for the last couple of years. And scientists, some of the scientists with us are working on it. Some new phenomena, some new things are being discovered, but this is a subject about which still a lot needs to be learned. However, in the meantime, behaving like a commercial entity, we need to diversify our generation resources. You can't be dependent on a single type of generation or a single geography. You can't be, in fact, dependent on a single market also. You've got to go international. And at the same time, we also have to see that how new technologies like storage or even utilizing excess energy for hydrogen generation and things like that, how that can be used to de-risk our total business model. Because honestly speaking, if you look at it as a businessman, my problem is not to forecast wind. My problem is to deliver the promises which I have made to my stakeholders. I mean, and here I mean more than my equity holders, even to my customer, I have to deliver power, whether wind blows or wind doesn't blow. So yes, it's a big problem. If you look at solar, with time, its behavior is also not highly predictable. But we have made some acquisitions in terms of specialized companies. And we are, for last few years, more than 5 years, are very strongly emphasizing on creating our in-house analytics and digitalization capabilities based on some very advanced sensors. We have PhDs working with us. So we are trying to solve this problem on our own in terms of having better forecasting, diversification, and learning from the world about whatever new they learn, how wind blows. See, when earlier used to be monsoon, we used to think, okay, monsoon means wind. Now you get monsoons, extended monsoons, and no wind.
Right. we have room for just one question, and I'll go to participants from who has joined on WebEx link. There's one interesting question that is asked by Mr. Abhishek Ranjan. He asks, should RE plants provide primary response with a suitable compensation mechanism? I'd like to ask, Suni sir. It's an interesting question.
Yeah. So, Mr. Abhishek Ranjan himself is an authority now. So, I would say you should be prepared for it. But if it is costing too much, then certainly regulators will see and say that somebody else should do that because we want economic power. But not having the feature at all and saying that we will not do any primary regulation in the design itself is something which we should question. And I will not mince words. For example, our nuclear. Entire France nuclear plant is turning down and running, but Indian nuclear plants, they are untouchables. You cannot touch because of the legacy. Don't create such legacies. Then you will, as Dr. Chatterjee has been again and again, you will hurt yourself. If you say that I am a renewable, I also give primary response. Everybody will like to have you. So that's my...
Perfect. Thank you. Any other thoughts, panelists, on this question?
Just one, as I said, renewables we are treating as grown-ups, and CEA regulations and CRC future grid code, which is coming, both are going to require the renewable generators also to provide primary response.
Wonderful.
So it's as clear as anything else.
I'll just add, we have done experiment and solar plants give much faster primary response, short primary response. Unlike boilers where the firing has to be changed, fuel has to change and all that. In solar, it's only an inverter. You will spill that much of sunshine. How does it matter? So that's possible. It's probably cheaper, but then it has to be incentivized, paid. That will be done. So I would say that we should go for it. After all, what is our target? 100% renewable. Somebody has to give them primary response at that time, and let's start grooming our plans for that. Thank you.
Great. Thank you. I think we can stop here. We are way beyond our schedule. So Nilanjan is giving me feelers sitting over there. Thank you so much. Now I request Professor Senroy to take control of the mic.
Thank you. And I have noticed that online there have been many interesting questions which I wish we could have taken up in this session. Very interesting questions about manufacturing and our dependency on imports. So, but unfortunately, in the interest of time, we have to close this session. So I would like to thank all our esteemed panelists for sparing their valuable time. All of them are extremely busy, unimaginably busy people. And the fact that they could come and spend half a day at IIT Delhi is really one of our biggest gains. Our students, researchers and all have benefited from the comments made. People have spoken very candidly. So I hope that all of us have understood what are the opportunities and what are the challenges in this great energy transition that we are going through currently in our country. So thank you very much, esteemed panelists. I would like to thank Professor Abhyankar. He is the Dean, and Deans are very busy people. So he has been working very tirelessly in planning the format for this program. So thank you very much, Abhijit. I'd like to thank Professor Khare, who had to leave because of some other engagement. I'd like to thank the Dean R&D for his support in the running of the COE. Of course, the COE is run with the money from Renew Power. So many thanks to Vaishali and Renew Power for their unstinted support to this Renew Power Center of Excellence, which is a great example of industry-academia collaboration. Thanks to Ashwini. She's tirelessly working behind the scenes, doesn't come forward to take any credit. I get all the credit for that. So thanks to her for planning this program. Thank you to all those who have joined virtually, as well as those who have come and attended this meeting in person, for your time, for your questions, for your attention. And please join us for a cup of tea outside the seminar hall. Thank you. So I would now, before that, I would now request Mr. Punendu Chaube, he's the Vice President of Renew, to come on stage and give some mementos to our panelists.
One more thing. Professor Nilanjan Sen Roy is the faculty coordinator for Renew COE, but he is moving out of this role very soon. So we would also like to give our token of appreciation to him. Thank you.